This video will show you how to implement an analysis for the Suqaba solver. We begin by selecting the FEM workbench and then create an analysis object by clicking on the big yellow A. The next step is to assign a material to your solid. To do so, we can click on the yellow sphere and a task panel will open. Then we can click on the drop-down button, browse the list and choose a material. Now you can click on the button again to close the list and scroll down to specify the geometry reference selector. Choose the solid selection mode, click the add button and then click anywhere on your part to assign the material. We can now scroll back up and click OK at the top of the task panel to finalize. The next step is to assign boundary conditions. Let's begin by adding a fixed boundary condition. So we click on the button, which will open up the task panel. Then we click on Add, and we can add the faces that will be subjected to the boundary conditions. You can add as many as you need. Now, let's add a pressure type boundary condition. Again, as before, when we click on the button, a task panel opens, where you can add the faces that will be subjected to these boundary conditions. For the pressure type boundary condition, we can specify the magnitude of the pressure field. We can also change the direction of application of pressure by clicking on the reverse direction button. We can now finally add a solver to our analysis. Unlike any other solver, you will be asked to enter an error threshold. This number is a percentage, and right now we see that it's set to 20%. You can view this as a quality requirement. The lower the requested error is, the higher the quality of the result. In the background, our solver will automatically generate and refine the mesh so as to comply with the requested error. As an example, what you see on the splash screen is a simulation of a turbine blade with our solver. The color map is an error indicator. The turbine blade on the right shows the initially generated mesh with high errors shown in red, while the turbine blade on the left shows our results with an adaptively refined mesh and low errors shown in blue. To know more about what's unique about our approach, we invite you to read our white paper and discovery deck. The links are in the description below. For the sake of this tutorial, we will set the error to 10%. Now we're done with the analysis implementation. The next video of the series will show us how to write and submit the job to the Suqaba solver.